Welcome to the session on vectors, application to mechanics. The objectives for this session are to model 3D motion in mechanics and vectors. Let's begin with an example. You can pause the video and have a go. Press play when you're ready to view the solutions. So let's begin with part A first. A particle P of mass 2 kilograms is acted on by the following forces: F1, F2 and F3 as given on your screen. Find the resultant force R acting on the particle P. So let's solve this. It's much easier when carrying out calculations to use the vectors rather than the IJK notation. So let's convert all the forces to vectors. F1 equals I plus 6j plus 5k. This now becomes the vector as highlighted on your screen, 1, 6 and 5. Minus I minus 5j plus 4k now becomes minus 1, minus 5, 4. F3, which is equal to minus 2i minus 6j minus 4k, now becomes vertically minus 2, minus 6, minus 4, as shown on your screen. We can now calculate the resultant force. So, adding all the x components gives us 1 plus minus 1 plus minus 2 equals minus 2. The y components, 6 plus minus 5 plus minus 6 equals minus 5. And 5 plus 4 minus 4 equals 5. And so our resultant force is minus 2 minus 5, 5. We can convert this back to IJK notation. So we have that R equals minus 2i minus 5j plus 5k newtons. Now let's have a go at part B. We are required to find the acceleration of the particle. So let's solve this. From part A, we have the value of R. We also have F equals ma, so we can apply this formula to R. And therefore, since R equals as shown, and the mass of the particle is 2 kilograms, we can plug these values into our formula in order to find the value of A, the acceleration. Dividing the expression through by 2 gives us the value of A, as shown here. So we have that the acceleration is equal to half times minus 2i minus 5j plus 5k meters per second squared. Now let's have a go at part C. We are required to find the magnitude of the acceleration. So let's solve this. From part B, we have the value of the acceleration. In order to find the magnitude, we simply apply Pythagoras' theorem. So we have the modulus of A equals the square root of minus 1 squared plus minus 2.5 squared plus 2.5 squared. Giving us the square root of 13.5 meters per second squared. Now let's have a go at part D. We are required to find the distance travelled by particle P in the first 5 seconds, given that the particle starts from rest. So let's solve this. Since the particle starts from rest, we know that the initial velocity u is equal to 0. And of course we have 5 seconds, so t equals 5. We also have from part C that A equals the square root of 13.5 meters per second squared. We want to find the distance which is travelled. Since P starts from rest, The acceleration acts in the direction of motion, so p is moving in a straight line with constant acceleration, and we can therefore use the formula s equals ut plus a half at squared, where s of course is the distance. Now we can plug in all the values that we have. We have u equals 0, t equals 5, and acceleration equals square root of 13.5. Giving us that s equals 45.9 meters. So the distance travelled is 45.9 meters. This brings us to the end of this session. If you have understood its contents, you should be able to model 3D motion in mechanics and vectors. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.